Welcome to Fictional Scientist. After this video, reality will never feel the same again. Every color you see, every sound you hear, every warmth you feel, none of it is out there. It's all inside your head. Light has no color, it only has wavelength. Sound has no tone, it's just air molecules vibrating. And here's the thing, you're blind to 99% of the electromagnetic waves flying around you right now. Radio waves, Wi-Fi signals, cosmic background radiation, they're passing through your body this very second, but your brain ignores them because seeing them wouldn't help you survive. So here's the question, what else are you missing? This isn't philosophy, this is neuroscience, this is evolutionary biology. This is the uncomfortable truth that scientists have been quietly discussing in labs for decades, while the rest of us go about our lives assuming that what we see is what's real. But it's not. Your brain isn't a camera. It's not passively recording the world around you like some biological GoPro strapped to your skull. Your brain is a prediction machine. It's a filter. It's a storyteller. And the story it tells you every single waking moment of your life is not the truth. It's a version of the truth. A simplified, compressed, edited for survival version designed to keep you alive long enough to pass on your genes. And once you understand this, once you really let it sink in, the world starts to feel different. The solidity of the chair you're sitting on becomes questionable. The colors you've trusted your whole life start to feel like borrowed paint. The sounds around you begin to echo with uncertainty, because if your senses are lying to you, if your perception is just a user interface designed to hide the complexity of reality, then what are you actually experiencing? And more importantly, what is reality actually like when no one is looking? Let's start with something simple. Something you do every single day without thinking about it. Let's start with seeing. Right now, you're reading these words, or at least you think you are. But here's what's actually happening. Photons, tiny packets of electromagnetic energy, are bouncing off the screen in front of you. These photons travel at the speed of light, about 186,000 miles per second, and they slam into the back of your eyeball, hitting a thin layer of tissue called the retina. The retina is packed with photoreceptor cells, rods and cones, about 120 million of them. When a photon hits one of these cells, it triggers a chemical reaction. The cell converts that light energy into an electrical signal. That signal travels down the optic nerve, a bundle of about 1 million nerve fibers, and enters your brain through the thalamus. From there, the signal gets routed to the visual cortex at the back of your brain. And here's where things get weird. Because your visual cortex doesn't just passively receive this information, it actively interprets it. It compares it to stored patterns. It fills in missing data. It makes educated guesses about what it's seeing based on past experience. And all of this takes time. About 80 milliseconds to be exact. That means that by the time you see the word in front of you, it's already 80 milliseconds in the past. You're not seeing the present. You're seeing a slightly delayed broadcast of reality, edited and processed by your brain's internal film crew. But it gets stranger because the information your brain is working with is incomplete. Your eyes don't send a complete image to your brain. They send fragments, edges, contrasts, motion. And your brain has to reconstruct the full picture from these fragments, like assembling a puzzle with half the pieces missing. How does it do this? By guessing, by using context, by filling in the blanks based on what it expects to be there. This is why optical illusions work. This is why you can look at a static image and see it move. This is why you can stare at a spinning spiral for 30 seconds, then look at a wall and watch it breathe. Your brain is constantly making predictions, and when those predictions clash with the incoming data, you see things that aren't there. But here's the really disturbing part. If your brain is filling in gaps and making predictions all the time, how do you know it's not filling in gaps right now? How do you know the world you're seeing is the world that's actually there? You don't. And that uncertainty is the first crack in the foundation of your perception. Let's zoom out for a moment. Let's talk about the light itself. You probably think of light as something neutral, something objective, something that just is. But light, as it exists in the physical world, has no color, it has no brightness, it has no warmth or coldness. It's just electromagnetic radiation, waves of energy oscillating at different frequencies. When we say a red apple is red, what we mean is that the apple's surface is absorbing most wavelengths of light and reflecting light at around 650 nanometers. That's it. The redness isn't in the apple, it's not in the light, it's in your head. Your brain takes that 650 nanometer wavelength, processes it through your cone cells, and generates the subjective experience you call red. And that experience, that quale, that felt sensation of redness, exists nowhere in the physical universe except inside your consciousness. This is why you can never know if your red looks the same as my red. We can both agree that we're seeing the same wavelength, but the actual subjective experience, the what it's likeness of seeing red, is locked inside each of our individual minds. It's a private event, an internal rendering. And this applies to everything you see. Blue isn't out there. Green isn't out there. The golden glow of a sunset, the deep blackness of a starless night, the shimmering silver of a fish underwater, all of it is being generated inside your skull. The world outside your head is colorless. It's a grayscale sea of vibrating energy. And your brain paints it in Technicolor to make it easier for you to navigate. Now think about what that means. If color is a fabrication, a useful fiction created by your visual system, what else is fabricated? What else is your brain making up? Let's talk about sound. You hear a dog barking outside. You hear traffic. You hear the hum of the refrigerator. You hear music. But none of these sounds exist outside your head, not in the way you experience them. Sound in the physical world is nothing more than pressure waves moving through air. When the dog barks, its vocal cords vibrate, creating rapid changes in air pressure. Those pressure waves travel outward in all directions, moving at about 343 meters per second, until they reach your eardrum. Your eardrum vibrates in response. Those vibrations get transmitted through 3 tiny bones in your middle ear, the hammer, anvil, and stirrup, which amplify the signal and pass it to the cochlea, a fluid-filled spiral structure in your inner ear. Inside the cochlea are thousands of tiny hair cells. When the fluid moves, these hairs bend, triggering electrical signals that travel down the auditory nerve to your brain. Your brain then takes these electrical impulses and constructs the subjective experience of sound. But here's the thing. The bark of a dog, the roar of an engine, the melody of a song, these are all creations of your auditory cortex. Outside your head, there is no sound. There's only the silent movement of molecules, a mechanical vibration passing through matter. The universe is silent. The sound is inside you. And just like with color, different species experience sound differently. A dog hears frequencies up to 65,000 hertz. You can only hear up to about 20,000 hertz. A bat hears ultrasonic frequencies that are completely inaudible to you. To them, the world is full of sounds you'll never experience. Sounds that, to you, simply don't exist. So when you're listening to music, you're not hearing the music as it truly is. You're hearing a species-specific translation of air pressure changes filtered through the narrow bandwidth of human auditory perception and rendered into a subjective experience by your brain. The song you love, the voice of someone you care about, the sound of rain on the roof, all of it is a biological hallucination. A convincing one, sure, but a hallucination nonetheless. Now let's talk about touch. Because if color and sound are illusions, surely touch is real, right? Surely when you press your hand against a wall, you're making direct contact with something solid, something undeniably real. Except you're not. At the atomic level, matter is almost entirely empty space. If you could zoom in on the atoms that make up your hand and the atoms that make up the wall, you'd see that they're mostly just vast expanses of nothingness with tiny particles whizzing around at incredible speeds. And here's the kicker. Your hand never actually touches the wall. Not in the way you think. What you feel as solidity is actually electromagnetic repulsion. The electrons in the atoms of your hand and the electrons in the atoms of the wall are both negatively charged, and like charges repel. So when you press your hand against the wall, the electrons in your hand are being pushed away by the electrons in the wall, and you interpret that repulsion as touch. You're not touching the wall. You're hovering above it on a microscopic cushion of electromagnetic force. You've never touched anything in your entire life. Not the ground beneath your feet, not the food you eat, not the people you hug. You've only ever felt the resistance of invisible force fields pushing back against you. And your brain, not knowing any better, interprets this resistance as solidity, as contact, as the feeling of touch. It creates the sensation of texture, of temperature, of pressure, even though none of these things exist in the way you experience them. The softness of a pillow, the coldness of ice, the roughness of sandpaper. These are all subjective experiences generated by your somatosensory cortex. Outside your nervous system, there is no softness, no coldness, no roughness. There are only molecules arranged in different configurations, vibrating at different speeds. Your sense of touch, like your sense of sight and sound, is a user interface, a way of simplifying and translating the incomprehensible complexity of the physical world into something your mind can work with. But if all your senses are interfaces, if everything you experience is a translation rather than the thing itself, then what is the thing itself? What is reality like when it's not being filtered through the narrow aperture of human perception? That's the question that keeps scientists awake at night. Because the answer might be that reality is nothing like what we think it is, and we might never be able to access it directly. Here's a fact that should disturb you. The vast majority of the universe is invisible to you. You think you're seeing the world, but what you're actually seeing is a tiny, narrow sliver of what's out there, a keyhole view of a much larger reality. Let's talk about the electromagnetic spectrum. This is the full range of electromagnetic radiation, from the longest radio waves to the shortest gamma rays. And sitting somewhere in the middle of this enormous spectrum is visible light, the light your eyes can detect. How much of the spectrum can you see? Less than 0.0035% of it. That's it. That's all you get. You're blind to more than 99.99% of the electromagnetic information that's constantly flooding the space around you. Right now, as you read these words, you're being bombarded by radio waves from nearby cell towers. Wi-Fi signals are passing through your body, carrying data from routers to devices. Microwaves from satellites are raining down on you from orbit. X-rays from distant cosmic events are piercing through the atmosphere and into your cells. And you can't see any of it. Your eyes are simply not equipped to detect these wavelengths. They're tuned to a very specific range, roughly 400 to 700 nanometers, and everything outside that range is invisible to you. But it's not just that you can't see it, it's that your entire perception of reality is built around this narrow window. You've constructed your understanding of space, of objects, of the world itself, based on this tiny fraction of available information. Imagine if you could suddenly see the full electromagnetic spectrum. Imagine if you could see radio waves. The world would look radically different. The air around you would be filled with glowing streams of data, pulsing with information. Your body would light up with the heat it radiates in the infrared spectrum. The walls of your room would become transparent to certain wavelengths, revealing the wiring and pipes hidden inside. You would be living in a completely different reality. Not a metaphorical reality, a perceptual reality. The world would look, feel, and behave differently because you'd be receiving different information. And here's the disturbing part. That world, the one you can't see, is just as real as the one you can. In fact, it might be more real because it contains more information. But you're locked out of it. Your biology won't let you in. You're like a person living in a house with only one window, convinced that the view from that window is the entire world, unaware that there are vast landscapes, entire ecosystems, whole continents of reality that exist just beyond your line of sight. Let's go deeper. Let's talk about what else you're missing. Your eyes can't see ultraviolet light, but bees can. To a bee, flowers have intricate ultraviolet patterns that guide them to nectar. These patterns are completely invisible to you. To you, a flower is one color. To a bee, it's a landing strip, glowing with information. You can't see infrared light, but snakes can. Pit vipers have special organs that detect infrared radiation, allowing them to see the heat signature of their prey in total darkness. To a snake, a warm-blooded animal is a glowing beacon in the night. To you, it's just darkness. You can't see magnetic fields. But birds can. Many migratory birds have magnetoreception, a biological compass that allows them to sense Earth's magnetic field and use it for navigation. To a bird, the planet is wrapped in invisible lines of force, guiding them across continents. To you, there's nothing there. You can't see polarized light. But mantis shrimp can. These creatures have the most complex eyes in the animal kingdom, with 16 types of photoreceptor cells compared to your measly 3. They can see colors you've never imagined, patterns of polarization that would blow your mind if you could perceive them. Each of these animals is living in a different perceptual reality. They're inhabiting the same physical world as you, but their experience of that world is completely different because their sensory equipment is tuned to different frequencies, different signals, different types of information. And none of them are seeing reality as it truly is. They're all seeing species-specific interfaces, customized by evolution to give them the information they need to survive and reproduce. So here's the question. If every species sees a different version of reality, which one is correct? Which one is true? The answer is none of them, and all of them. Each species is accessing a different subset of the available information, translating it through their unique sensory systems and constructing a perceptual model that works for them. But none of these models is the territory. They're all maps, simplified representations, useful fictions. And you're stuck in your map, convinced it's the territory, unaware of how much you're missing. Let's talk about time. Because if space is a construct, if your perception of the physical world is a filtered interface, what about your perception of time? You experience time as a linear flow, a river carrying you from the past through the present and into the future. This feels undeniable. It feels like a fundamental feature of reality. But it's not. It's a feature of your perception. Einstein showed us that time is relative. It doesn't flow at the same rate for everyone. An astronaut orbiting Earth experiences time slightly slower than someone on the ground. A person standing at the base of a mountain ages slightly faster than someone at the top. These aren't thought experiments. These are measurable, observable facts. Time is flexible. It bends, it stretches. It's woven into the fabric of space-time, and it behaves according to the rules of physics, not the rules of human intuition. But even beyond relativity, there's something stranger happening with time. Something that has to do with how your brain processes it. Your perception of time is not constant. It speeds up and slows down depending on your mental state. When you're bored, time drags. When you're having fun, it flies. When you're in danger, it dilates. People who've been in car accidents often report that time seemed to slow down and that they saw everything happening in slow motion. This isn't an illusion, or rather, it's the same kind of illusion that everything else in your perception is. Your brain is adjusting the playback speed of your experience based on the amount of information it's processing. When you're engaged and focused, your brain is taking in a lot of data, and time feels like it's passing quickly. When you're bored, your brain is processing less, and time feels like it's crawling. But here's the deeper issue. Your sense of now, the present moment, doesn't actually exist in the physical world. There's no objective now that everyone shares. The present is a construct, a thin slice of perception that your brain creates by stitching together signals that arrived at slightly different times. Remember, it takes about 80 milliseconds for visual information to reach your consciousness. It takes about 10 milliseconds for auditory information, and it takes varying amounts of time for tactile information, depending on where on your body the sensation originates. So, when you see a door slam and hear the sound at the same time, you're not actually experiencing those events simultaneously. Your brain is time shifting the signals, delaying the faster one or speeding up the slower one to make them feel synchronized. Your brain is editing reality in real time, adjusting the timing of events to create the illusion of a coherent present moment. But that moment is artificial. It's a perceptual frame, a snapshot taken from a continuous flow of information, packaged and delivered to your consciousness as now. And if the present is a construct, if now is just a convenient fiction your brain tells you, what does that mean for your sense of self, your sense of agency, your feeling that you're experiencing reality as it unfolds? It means you're always living in the past. You're always reacting to echoes of events that have already occurred. You're a ghost haunting your own history, forever a few dozen milliseconds behind the cutting edge of reality. So, why does your brain do this? Why does it filter reality, compress information, fabricate colors and sounds, and distort time? Why doesn't it just show you the truth? Because the truth would kill you. Evolution is a brutal engineer. It doesn't care about your happiness. It doesn't care about your enlightenment. It doesn't care if you understand the universe. It only cares about one thing. Did you survive long enough to reproduce? And here's the uncomfortable fact. Seeing reality as it truly is doesn't help you survive. In fact, it might get you killed. Let me introduce you to Donald Hoffman. He's a cognitive scientist at the University of California, Irvine, and he spent the last several decades working on a theory that should disturb anyone who cares about truth. It's called the interface theory of perception, and it makes a radical claim. Evolution did not shape our senses to show us reality. It shaped them to hide reality. Hoffman ran thousands of evolutionary simulations using a mathematical framework called evolutionary game theory. He created virtual organisms with different sensory strategies. Some organisms were tuned to see reality as it truly is. They had access to the full unfiltered truth of their environment. Other organisms were tuned to see only fitness payoffs. They couldn't see the objective world. They could only see what was useful for survival, where the food was, where the danger was, what helped them and what hurt them. Then he let them compete, and the results were stark. In every single simulation, the organisms that saw the truth went extinct. The organisms that saw only fitness payoffs thrived. Why? Because truth is expensive. Reality is complex. Processing the full depth of objective information about the world requires enormous computational resources. It's slow, it's energy intensive, and in a life or death situation, slow gets you killed. Imagine you're walking through a forest and you see a tiger. If your brain had to process the full quantum level reality of that tiger, the arrangement of subatomic particles, the electromagnetic fields, the complex molecular bonds holding its cells together, you'd be dead before you finish thinking about it. But you don't need to know the quantum physics of a tiger to survive an encounter with one. You just need to know. Tiger. Danger. Run. Your brain gives you a simplified icon, a user-friendly symbol that says threat without burdening you with the irrelevant details. And that icon, that symbol, is enough to keep you alive. So evolution favored the liars. It favored organisms that traded truth for speed, accuracy for utility. Over millions of years, the truth seers were weeded out, and the survivors, us, are the descendants of organisms that were optimized not for knowing reality, but for navigating it efficiently. You are the product of a long line of pragmatic liars. Your ancestors didn't need to see the world as it truly was, they just needed to see it well enough to eat, avoid being eaten, and pass on their genes. And your perceptual system is the legacy of that evolutionary strategy. Hoffman uses a powerful metaphor to explain this. He compares perception to the desktop interface on a computer. When you look at your computer screen, you see icons, a blue folder, a trash can, a document. These icons are useful. They allow you to interact with the computer without needing to understand the underlying code, the voltage changes in the circuits, the binary data streaming through the processor. If the computer showed you the truth, if it displayed raw machine code instead of icons, you wouldn't be able to use it. The truth would be incomprehensible. The icons hide the complexity to make the system usable. Hoffman argues that reality is the same way. The world you see, the colors, the shapes, the objects, they're all icons. They're a user-friendly interface designed to help you interact with reality without overwhelming you with its true complexity. The apple on the table isn't red and round because the apple is red and round. It's red and round because your visual system has rendered it that way, using a simplified icon that means edible fruit. The actual apple at the level of quantum fields and particle interactions looks nothing like what you see. The redness, the roundness, the solidity, these are perceptual shortcuts, lies that make sense, lies that work. And this is where it gets unsettling, because if your senses are lying to you, if everything you see is an icon rather than the thing itself, how do you ever get access to reality? How do you see behind the interface? Hoffman's answer is bleak. You don't. You can't. Your biology won't let you. You're trapped inside the user interface, and no matter how hard you try, no matter how sophisticated your instruments become, you're still looking at icons. You're still interacting with the map, not the territory. The only way to see reality as it truly is would be to step outside your sensory system entirely. And that's not possible, because you are your sensory system. You are the interface. There's no you independent of the perceptual machinery that constructs your experience. You're locked in, and the walls of your prison are invisible because they're made of the very tools you use to see. Let's test this idea. Let's think about something that seems absolutely undeniably real: space. You experience space as a three-dimensional container. There's up and down, left and right, forward and backward. Objects exist at specific locations. Distances can be measured. Space feels like an objective backdrop, a neutral stage on which the drama of reality unfolds. But what if space isn't fundamental? What if space, like color and sound, is just another icon? Physicists are starting to think this might be true. There's growing evidence that space is not a feature of reality itself, but an emergent property of something deeper, something we don't have direct access to. In quantum mechanics, particles can be entangled, meaning they're connected in a way that transcends spatial separation. When you measure one entangled particle, the other particle, no matter how far away it is, instantly responds. This happens faster than light could travel between them, which violates our intuitive sense of how space works. Einstein called this spooky action at a distance, and he hated it. But experiments have confirmed it over and over again. Entanglement is real, and what entanglement suggests is that space, the sense of separation, the feeling that you are here and something else is there, might be an illusion. At the deepest level of reality, there might be no distance, no separation, just connections, relationships, information. Space might be the icon your brain uses to organize these connections. It's a way of mapping relationships in a format that your sensory system can work with. But the map is not the territory. The space you perceive is not the space that exists. It's a perceptual construct, a rendering. And if space is a construct, what about objects? What about things? You see a chair, it's solid, it's separate from the table next to it. It has a location, a shape, a color. It feels like a thing. But zoom in and the chair dissolves. It's made of molecules. Zoom in further and the molecules dissolve into atoms. Zoom in further and the atoms dissolve into subatomic particles. And those particles aren't really particles in the way you think. They're excitations in quantum fields, waves of probability smeared out across space and time. At the deepest level, there is no chair. There's just a pattern of vibrations in a field, a temporary ripple in the quantum foam, and your brain takes that pattern and renders it as a solid, separate object, because that's useful, because you need to know whether you can sit on it. But the solidity, the separateness, the thingness of the chair, it's all perceptual, it's all interface. The chair is an icon, and you're sitting on a lie. Here's where it gets existential. If objects are icons, if space is an icon, if time is an icon, if colors and sounds and sensations are icons, what about you? What about the sense of self? The feeling that there's someone inside your head looking out through your eyes, experiencing the world. Is that an icon too? Neuroscience suggests it might be. Your sense of self, your feeling of being a unified, continuous person, is a construct. It's something your brain creates by stitching together sensory information, memories, and predictions into a coherent narrative. But that narrative is fragile. It can be disrupted. People with brain injuries, people with conditions like hemispatial neglect or anosognosia, lose parts of their sense of self. They stop perceiving one half of their body. They deny that their paralyzed limbs belong to them. The self fractures, and what remains is a person who is considered whole, even though a chunk of their perception is missing. And even in healthy brains, the self is constantly being updated, rewritten, adjusted. Your memories aren't fixed recordings. They're reconstructed every time you recall them, and each time you reconstruct them, you change them slightly. The person you were 10 years ago is not the same as the person you are now. Not just in terms of your body, but in terms of your memories, your identity, your sense of who you are. The self is a story your brain tells you. And like all stories, it's a simplification, a useful fiction, an icon that represents the complex, distributed process of being you, packaged into a single, coherent character that can move through the world and make decisions. But the character isn't you. You are the process. You are the firing of neurons, the flow of information, the constant updating of predictions and models. And that process is too complex to perceive directly. So your brain gives you a character, a protagonist, an I that feels like it's in control. But it's not. The I is just another icon. And behind the icon is a vast humming network of activity that you'll never experience directly because you are that network. You're locked inside yourself, using yourself as the interface to understand yourself. And the recursion makes it impossible to ever step outside and see the truth. Let's shift gears. Let's talk about what your brain is actually doing while you're experiencing all these icons. You think perception is passive. You think your brain is sitting back, receiving signals from the outside world, and displaying them on the screen of your consciousness like a neutral observer. But that's not how it works. Your brain isn't waiting for reality to tell it what's out there. Your brain is guessing. It's making predictions constantly about what's going to happen next, what you're going to see, what you're going to hear, and it's comparing those predictions to the incoming sensory data. When the predictions match the data, you experience smooth, seamless perception. When they don't match, you experience surprise, confusion, or the need to update your model. This is called predictive processing, and it's one of the most important ideas in modern neuroscience. It flips the traditional model of perception on its head. In the old model, perception was bottom-up. Sensory signals came in from the outside world, traveled up through the sensory pathways and reached the brain, where they were interpreted. Reality flowed from the outside in. But in the predictive processing model, perception is top-down. Your brain is constantly generating predictions about what it expects to encounter, and those predictions flow downward through the system, shaping and filtering the incoming signals. Reality flows from the inside out. Your brain is not passively receiving the world, it's actively constructing it. Here's an example. You're in a dark room and you hear a creaking sound. Immediately, your brain generates a prediction. Maybe it's the floorboards settling. Maybe it's the wind. Maybe it's an intruder. Each of these predictions comes with a set of expectations. If it's the floorboards, you expect the sound to be soft and irregular. If it's the wind, you expect it to be rhythmic. If it's an intruder, you expect it to be followed by footsteps or voices. Your brain listens to the next few seconds of sound and compares it to these predictions. If the sound matches one of the predictions, that prediction is strengthened and your perception solidifies. If it doesn't match, your brain generates new predictions and keeps updating until it finds one that fits. But here's the key. The prediction comes first. Your brain doesn't wait for reality to fully reveal itself. It guesses, and then it checks its guess against the data. And most of the time, the guess is so close that you don't even notice the process happening. You just experience a seamless, coherent world. But sometimes the guess is wrong. And that's when things get interesting. Optical illusions are a perfect example of predictive processing in action. Take the famous Ames room illusion. You look through a window into a room and you see two people standing in opposite corners. One person looks enormous and the other looks tiny. But when they switch places, their sizes seem to reverse. The giant becomes small and the small one becomes giant. What's happening? The room isn't actually rectangular, it's distorted. One corner is much closer to you than the other, but your brain assumes the room is rectangular because that's what rooms usually are, so it interprets the difference in retinal size as a difference in the size of the people, not a difference in their distance. Nope. Your brain made a prediction, the room is rectangular, and that prediction overrode the raw sensory data. You saw what your brain expected to see, not what was actually there. This happens all the time, not just with illusions, but with everyday perception. Your brain is constantly filling in gaps, smoothing over inconsistencies, and making educated guesses about what's out there. And most of the time, it's right. But when it's wrong, you don't see reality. You see your brain's best guess. And here's the disturbing part. You can't tell the difference. When your brain is filling in a gap, when it's making a prediction, it doesn't label that information as guess or fabrication. It feels just as real as everything else. You experience it as perception, not imagination. Your brain is lying to you, and it's doing it so smoothly, so convincingly that you never notice. Let's talk about blind spots. You have a literal blind spot in each of your eyes, a place where the optic nerve connects to the retina, and there are no photoreceptors. It's about the size of 6 full moons lined up next to each other, and you can't see anything there. There's just nothing, except you never notice it, because your brain fills it in. Your brain looks at the area around the blind spot, figures out what should be there based on context, and paints over the gap with its best guess. It manufactures visual information out of nothing and inserts it into your perception so seamlessly that you never know it was missing in the first place. This is not a minor quirk. This is a fundamental feature of how your brain works. Your brain doesn't passively display the world as it is. It actively constructs a version of the world that makes sense, even if that means inventing parts of it. And if your brain can invent visual information to cover a blind spot, what else is it inventing? How much of what you see is real data, and how much is your brain's educated guess? There's no way to know, because your perception doesn't come with a watermark that says fabricated by your visual cortex. It all feels equally real. You're not seeing reality. You're seeing a heavily edited, annotated, best guess simulation of reality, generated by a prediction engine that's optimized for speed and utility, not truth. This predictive model has profound implications for consciousness. Because if your brain is generating predictions about what's going to happen next, it's also generating a sense of expectation, a sense of flow, a sense of narrative. Your experience of the present moment isn't just a static snapshot, it's a continuous story, unfolding in time, driven by your brain's predictions about what comes next. Think about watching a movie. You don't experience it as a series of disconnected frames. You experience it as a continuous narrative because your brain is predicting the next frame and the next and the next, stitching them together into a seamless flow. The same thing happens with your life. Your brain is predicting the next moment and the next and the next, and those predictions create the feeling of time moving forward, of events unfolding, of a story being told. But what if the predictions stop? What if your brain's ability to predict the future breaks down? This happens in certain neurological conditions. People with severe schizophrenia, for example, often experience a breakdown in predictive processing. Their brains lose to generate coherent predictions, and the world becomes chaotic, unpredictable, overwhelming. They hear voices because their brain can't distinguish between internal predictions and external sounds. They see patterns that aren't there because their brain is trying to make sense of the noise and failing. In a sense, they're seeing reality more directly than you are. They're experiencing the raw, unfiltered stream of sensory information without the smoothing, without the predictions, without the narrative, and it drives them mad. Because we need the predictions. We need the story. Without it, the world is just noise. Your sanity depends on your brain's ability to guess correctly about what's going to happen next, and to weave those guesses into a coherent, continuous experience. You're not perceiving reality. You're perceiving a story about reality, written in real time by your brain's prediction engine. And that story is the only version of the world you'll ever know. So far, we've talked about how your brain filters, edits, and fabricates your experience. But there's another layer to this. It's not just that your brain distorts the information it receives, it's that you're not receiving most of the information in the first place. Your sensory systems are hardware. They have physical limitations. There are signals in the world that your biology simply cannot detect. And those signals, those pieces of information, are part of reality too. But they're invisible to you. Let's start with something simple. Air pressure. You can't feel air pressure directly. You can feel wind, the movement of air. But the static pressure of the atmosphere pressing down on you at 14.7 pounds per square inch, you can't feel it. You've adapted to it. It's always there, so your sensory system ignores it. But if you go up in an airplane or dive deep underwater, the pressure changes and suddenly you can feel it. Your ears pop, your sinuses ache. The change is perceptible, but the baseline is not. You're surrounded by pressure constantly and you have no awareness of it. It's there, it's real. It's exerting force on every square inch of your body, but you can't sense it because your body has normalized it. Now think about how many other things might be like that. Forces, fields, energies that are constantly present but invisible to you because you've never evolved the hardware to detect them. Gravitational waves, for example. We just recently built instruments sensitive enough to detect them. Ripples in space-time caused by colliding black holes billions of light years away. These waves pass through the Earth, through your body, constantly. But you can't feel them. They're there. They're real, but they're outside the range of your sensory equipment. Same with neutrinos. Trillions of them are passing through your body every second, tiny subatomic particles that barely interact with matter. They zip through the earth like it's not even there, and you can't feel a single one. Magnetic fields. You're surrounded by them. The Earth's magnetic field, the magnetic fields generated by electrical devices. They're real, they have direction and strength, but you can't sense them. You can't navigate by them like a bird can. To you, they simply don't exist. And this is the problem. Your perception is not a window into reality. It's a narrow slit, a peephole. You're seeing a tiny fraction of what's out there, and you're calling that fraction the world. But the world is so much bigger, so much stranger, so much more complex than the slice you have access to. And you're biologically locked out of most of it. Let's talk about quantum mechanics, because this is where the limits of human perception become almost surreal. At the macroscopic level, the level of chairs and tables and people, reality seems solid, predictable, deterministic. Objects have definite locations. Cause and effect work the way you expect. The future feels open, but the past feels fixed. But at the quantum level, none of that is true. Particles don't have definite positions until you measure them. They exist in a state of superposition, a kind of smeared out cloud of probability. And when you measure them, when you interact with them, the cloud collapses and the particle suddenly has a definite location. This is the famous observer effect. The act of measurement changes the system. Not because your measuring device is clumsy or intrusive, but because the system literally doesn't have a definite state until you force it to choose one. And this has led to a lot of confusion. A lot of people hear about the observer effect and think it means consciousness creates reality. They think it means your mind has some kind of magical power to shape the universe just by looking at it. But that's not what it means. The observer in quantum mechanics doesn't have to be conscious. It just has to be a macroscopic system that interacts with the quantum system. A photon hitting a detector is an observer. A molecule bumping into an atom is an observer. Consciousness has nothing to do with it. The confusion arises because we use human-level language to describe quantum phenomena, and that language doesn't fit. We talk about observation and measurement, and those words carry connotations of awareness, of intention, of mind. But in quantum mechanics, they just mean interaction. They mean the system became entangled with the environment in a way that collapsed the superposition. So no, your mind is not creating reality. But here's what is true. Reality at the quantum level is fundamentally different from reality at the macroscopic level. And your perception, which evolved to deal with the macroscopic level, simply doesn't work down there. You can't visualize a particle in superposition. You can't imagine what it's like for something to be in two places at once. Your brain doesn't have the hardware to render that kind of information. So instead it gives you metaphors, waves, particles, clouds of probability. But none of these metaphors are accurate. They're just the closest your perceptual system can get to describing something it was never designed to perceive. And this raises a disturbing question. If your brain can't perceive quantum phenomena, if it can't even form an accurate mental model of what's happening at the smallest scales of reality, then how much of reality is permanently beyond your reach? How much of the universe is fundamentally, irreducibly invisible to you? Not because it's too far away or too small, but because your perceptual system is simply not built to handle it. The answer might be most of it. Here's another example: probability and statistics. Humans are terrible at understanding probability. We make systematic errors. We see patterns in random noise. We overestimate rare events and underestimate common ones. We fall for the gambler's fallacy, the conjunction fallacy, the base rate fallacy. Why? Because our brains didn't evolve to think probabilistically. They evolved to think in terms of stories, causes, and agents. We're pattern recognition machines, and we're so good at finding patterns that we find them even when they're not there. You flip a coin 5 times and it comes up heads every time. Your brain screams, the next one has to be tails. But the coin has no memory. The probability is still 50-50. Your brain is imposing a narrative, expecting the universe to balance out, but the universe doesn't work that way. This is a fundamental mismatch between how reality works and how your brain works. Reality is probabilistic, especially at the quantum level, but your brain is deterministic. It wants causes, it wants reasons, it wants stories, and when reality doesn't give you those things, your brain makes them up. This is why conspiracy theories are so appealing. The world is full of randomness, coincidences, and chaos, but your brain doesn't like randomness. It wants to believe that things happen for reasons, that there's a plan, a pattern, an agent in control. So when something bad happens, something inexplicable, your brain invents an explanation. It finds a villain, it constructs a narrative, and that narrative feels true. It feels more true than randomness because randomness is harder for your brain to process. Stories are easier, agents are easier, intentions are easier. Your brain is optimized for a world of predators and prey, friends and enemies, intentions and actions. It's not optimized for a world of statistics, quantum fields, and impersonal forces. So when confronted with that world, your brain does what it always does. It simplifies, it translates, it lies. So far, we've been talking about individual perception, but here's another layer: collective perception, the social construction of reality. You might think, okay, my perception is limited, but at least we all agree on the basics, right? We all see the same table, the same sky, the same world. But do you? Let's run an experiment. Take 100 people and show them a color. Call it blue. Ask them to describe it. Most of them will say blue. But are they seeing the same blue? There's no way to know. You can't step inside someone else's visual cortex and compare the subjective experience of blueness. You can only compare behavior. And as long as everyone agrees to call that wavelength blue, you assume you're seeing the same thing. But you might not be. One person's blue might be another person's green, subjectively speaking. And you'd never know because you've both learned to attach the label blue to that particular wavelength. This is called the problem of qualia. Qualia are the subjective, felt qualities of experience. The redness of red, the painfulness of pain, the what it's likeness of seeing, hearing, feeling. And there's no way to know if your qualia are the same as mine. We can agree on the physics, we can agree on the wavelengths, but the experience, the thing you're actually feeling when you see blue, is locked inside your head, inaccessible to anyone else. And if we can't even agree on the subjective experience of color, what about more complex things? What about beauty, justice, truth? These are not just social constructs, they're perceptual constructs. They depend on your brain's ability to process and interpret information. And different brains process information differently. Culture shapes perception. Language shapes perception. Your experience of reality is not just a product of your biology. It's also a product of your upbringing, your environment, your cultural context. There's a famous example from linguistics. The Himba people in Namibia have a different color vocabulary than English speakers. They don't have a single word for blue. They use the same word for blue and green. And when you show them a color that English speakers would call blue, they have a hard time distinguishing it from green. But they have more words for different shades of green than English speakers do. And they can distinguish between shades of green that look identical to English speakers. Same eyes, same photoreceptors, but different perceptual categories. Their language has shaped the way they see the world. And this effect goes beyond color. Studies have shown that speakers of languages with gendered nouns perceive objects differently depending on the grammatical gender. If your language assigns feminine gender to bridge and masculine gender to clock, you're more likely to describe bridges as elegant and clocks as strong, even though there's nothing inherently gendered about these objects. Your language is not just a tool for describing reality. It's a filter that shapes the way you perceive reality in the first place. And if language can shape perception, what about other cultural factors? What about religion, politics, media? You live in a bubble of shared assumptions, shared narratives, shared perceptual categories. And that bubble feels like reality. It feels like the objective, neutral truth. But it's not. It's a consensus illusion, a collectively agreed upon version of reality that only exists because everyone in your culture is using the same perceptual filters. Step outside your culture and the illusion cracks. People see the world differently. They prioritize different things. They perceive different patterns. And they're just as convinced as you are that their version is the true one. So which version is true? Which culture's perception is correct? None of them. And all of them. They're all maps, not territories. They're all simplified, culturally specific interfaces designed to make sense of a reality that's too complex to perceive directly. You're not seeing the world as it is. You're seeing the world as your culture has taught you to see it. And that's yet another layer of filtering between you and whatever's really out there. Let's go even deeper. Let's talk about attention. You can't perceive everything at once. Your brain has limited processing power, and it has to choose what to focus on and what to ignore. This is called selective attention, and it's one of the most powerful filters in your perceptual system. There's a famous experiment called the invisible gorilla test. You're shown a video of people passing basketballs back and forth, and you're asked to count how many times the people in white shirts pass the ball. Halfway through the video, a person in a gorilla suit walks into the middle of the scene, beats their chest, and walks off. And about half the people watching the video don't see the gorilla. They're so focused on counting passes that their brain filters out the gorilla entirely, even though it's right there in the center of the frame, impossible to miss. Your attention is not a passive spotlight, it's an active filter. And when your attention is focused on one thing, your brain actively suppresses other things, even things that are visually obvious. This means you're constantly missing huge chunks of reality because your brain has decided they're not important. You're walking around in a state of partial blindness, unaware of how much you're not seeing. And this isn't a bug, it's a feature. If your brain tried to process everything, you'd be overwhelmed. You'd be paralyzed by the sheer volume of information. So your brain filters aggressively, and what you experience as reality is just the small subset of information that your attention has decided to let through. But here's the problem. You don't know what you're missing. The things you're not paying attention to simply don't exist in your conscious experience. And because they don't exist, you can't know they're there. You're living in a spotlight, convinced that the lit area is the entire stage, unaware of the vast darkness surrounding you. We've talked about how your brain constructs the external world. But what about the internal world? What about the sense of self? The feeling that there's a you experiencing all of this? That, too, is a construct, and it's just as fragile as everything else. Your sense of self is not a thing. It's a process. It's an ongoing activity of your brain, constantly updating, constantly revising, constantly weaving together sensory input, memories, and predictions into a coherent narrative. But that narrative can break. And when it does, the results are disturbing. Consider split brain patients. These are people who've had the corpus callosum, the bundle of nerves connecting the left and right hemispheres of the brain, severed, usually as a treatment for severe epilepsy. After the surgery, the two hemispheres can no longer communicate, and this leads to bizarre symptoms. If you show a split brain patient an image to only their right visual field, which is processed by the left hemisphere, they can describe it. But if you show them an image to only their left visual field, processed by the right hemisphere, They can't describe it even though they can point to it with their left hand. It's as if there are two separate consciousnesses in one body. The left hemisphere has language and can talk about what it sees. The right hemisphere doesn't have language but can still perceive and respond. So, which one is the real person? Which hemisphere contains the self? The answer is both, and neither. The self is not located in one hemisphere or the other. It's an emergent property of the whole system working together. And when the system is divided, the self fractures. This tells us something profound. The self is not a unitary, indivisible thing. It's a collection of processes, and those processes can be separated, disrupted, or altered. Here's another example. Hemispatial neglect. This is a condition that sometimes occurs after a stroke in the right hemisphere. People with hemispatial neglect lose awareness of the left side of space, not just the left side of their visual field, the left side of their entire perceptual world. If you ask them to draw a clock, they'll draw all the numbers on the right side. If you ask them to eat a meal, they'll only eat the food on the right side of the plate. If you ask them to describe a room, they'll describe only the right half. And here's the disturbing part. They're not aware that anything is missing. They don't perceive a gap. They don't feel like half their world is gone. From their perspective, everything is normal. The left side simply doesn't exist for them. This is what happens when a part of your perceptual system breaks down. You don't see a blank space. You don't experience an absence. You just construct a new version of reality that doesn't include the missing information. And that new version feels complete. Your brain is so committed to maintaining a coherent sense of reality that it will rewrite the world to cover up its own failures. And you'll never know the difference. Your memories are the same way. You think of memory as a recording, a faithful archive of your past, but it's not. Every time you remember something, you're reconstructing it. You're piecing together fragments, filling in gaps, and updating the memory based on new information. And every time you reconstruct a memory, you change it. Details get added. Details get lost. The emotional tone shifts. The narrative evolves. Studies have shown that you can implant false memories in people just by suggesting them repeatedly. You can make someone remember something that never happened, and they'll swear it's true. They'll describe it in vivid detail. They'll defend it against contradiction. Because the memory feels real. It has the same subjective quality as a real memory. There's no internal tag that says, fabricated by your hippocampus. It's all just memory, and your brain treats it all the same way. So how do you know which of your memories are real? How do you know which parts of your past actually happened and which parts are reconstructions, confabulations, stories your brain has told you so many times that you've come to believe them? You don't. You can't. Your past, like your present, is a construct, a narrative, a story your brain is telling you about who you are and where you came from. And that story might be mostly accurate, or it might be full of errors, or it might be a complete fiction. There's no way to verify it because the only tool you have for verifying it is the same brain that constructed it in the first place. You're trapped inside a hall of mirrors, and every reflection is yourself, and you can't tell which one is the original. Let's talk about why this matters. Why does it matter that your perception is a construct? That your senses are filters, that your brain is lying to you? It matters because it changes the way you think about truth, about knowledge, about reality itself. For thousands of years, humans have assumed that the path to truth is through observation. Look at the world, study it carefully, and you'll discover its secrets. This is the foundation of science, of empiricism, of the entire Enlightenment project. But if your observations are always filtered through a perceptual interface that's optimized for survival rather than truth, then what are you actually observing? You're observing your interface. You're studying your map, not the territory. This doesn't mean science is useless. Science works. It builds bridges, cures diseases, sends rockets to Mars. But what science is really doing is finding patterns in the interface. It's discovering the rules of the map. And those rules are useful. They're predictive. They allow you to navigate reality more effectively. But they're not reality itself. They're a model of reality, filtered through human perception, translated into human language, constrained by human cognition. Einstein's equations describe gravity beautifully, but do they tell you what gravity is? Do they reveal the fundamental nature of space-time? Or are they just a mathematical map, a set of symbols that predict how objects will move without actually explaining why? Quantum mechanics predicts the behavior of particles with stunning accuracy. But does it tell you what a particle is? Does it explain the collapse of the wave function? Or is it just a calculational tool, a way of organizing your observations into a coherent framework? Physics gives you tools. It gives you predictions, but it doesn't give you access to the thing in itself, the underlying reality that exists independent of your perceptual apparatus. Kant understood this centuries ago. He drew a distinction between phenomena, the world as it appears to us, and noumena, the world as it is in itself. And he argued that we can never access the noumena. We're forever trapped in the phenomenal realm, the realm of appearances, the realm of our own constructed experience. And modern neuroscience is proving him right. Your brain is the barrier. Your senses are the walls, and there's no way out. But here's the paradox. If you can never access reality directly, if you're always seeing through a filter, how do you even know there's something beyond the filter? How do you know you're missing anything? Maybe the interface is all there is. Maybe reality is just the sum total of all possible perceptual interfaces, and there's no deeper truth hiding underneath. This is a version of idealism, the philosophical position that reality is fundamentally mental, that consciousness is primary and matter is derivative. It's been around for millennia, and it keeps coming back because it solves a lot of problems. If reality is just a collection of experiences, if there's no objective world independent of perception, then you don't have to explain how the objective world gives rise to subjective experience. You start with experience and build from there. But this creates its own problems. If reality is just perception, whose perception? Yours, mine, everyone's? And what happens to reality when no one is perceiving it? Does it disappear? Does it go dormant? Does it exist in some kind of potential state, waiting for an observer to collapse it into actuality? These are not easy questions. And the uncomfortable truth is that science doesn't have definitive answers. Science can describe how perception works. It can map the neural pathways, it can identify the mechanisms, but it can't tell you what perception is in any fundamentals. It can't tell you why there's something it's like to be you, why there's a subjective first-person experience associated with the firing of neurons in your brain. This is the hard problem of consciousness, and despite decades of research, we're no closer to solving it. We can correlate brain activity with conscious states. We can even manipulate brain activity to change conscious states. But correlation is not explanation, and manipulation is not understanding. You can turn the lights on and off with a switch, but that doesn't mean you understand electricity. You're just interacting with an interface, pressing buttons, observing effects, without ever accessing the underlying reality. And the same is true for consciousness. You're experiencing it, you're reporting on it, but you're not explaining it. You're just describing the interface. Here's where it gets existential. If your sense of self is a construct, if your perception of reality is a construct, if even your memories and your feeling of continuity are constructs, then what are you? Are you the interface? Are you the process that generates the interface? Are you the awareness that experiences the interface? Or are you something else entirely? Something that can't be reduced to brain activity, something that exists beyond the physical. Materialists say you're nothing but the physical processes. You are your brain. When the brain stops, you stop. Consciousness is an emergent property of neural activity, and when the activity ceases, consciousness ceases. Dualists say you're something more. You have a mind that's separate from your brain, a soul, a spirit, something non-physical that interacts with the physical world but isn't reducible to it. And idealists say the question is backwards. The physical world is a construct of consciousness, not the other way around. You're not in the universe is in you. Each of these positions has problems. Materialism can't explain qualia, the subjective feel of experience. Dualism can't explain how a non-physical mind interacts with a physical brain. And idealism can't explain why the world behaves so consistently, so predictably, as if it's following objective rules independent of anyone's thoughts. The truth might be that we're asking the wrong question. We're trying to reduce consciousness to something else, to explain it in terms of something more fundamental. But what if consciousness is fundamental? What if it's not a product of the physical world, but a basic feature of reality, like space or time or energy? This is panpsychism, the idea that consciousness is everywhere, that it's a property of matter itself, present at every level of organization, from atoms to galaxies. It's a strange idea and it feels mystical, but it solves the hard problem by refusing to engage with it. If consciousness is fundamental, you don't have to explain how it arises from non-conscious matter. It's already there. But even if panpsychism is true, it doesn't answer the question of what you are. Because you're not just conscious. You're this particular pattern of consciousness, this specific bundle of experiences, memories, and sensations. And that pattern is temporary. It's held together by the ongoing activity of your brain. And when that activity stops, the pattern dissolves. The individual drops of consciousness that made you up might persist, but the you-ness, the specific organization, the identity, that's gone. So maybe you're a temporary eddy in the stream of consciousness, a brief, localized pattern that emerges, persists for a few decades, and then dissipates back into the flow. That's both comforting and terrifying. Comforting because it means you're part of something larger, something that doesn't end when you do. Terrifying because it means you're not as solid, not as permanent, not as real as you feel. You're a wave, not a particle, and waves don't last. So where does this leave us? What do we do with the knowledge that our perception is a lie, that our senses are filters, that reality might be fundamentally inaccessible to us? Do we despair? Do we give up on the search for truth? No, because even though we can't access reality directly, we can learn about our interface. We can study the ways our perception distorts information. We can identify our biases, our blind spots, our systematic errors, and we can build tools to compensate for them. This is what science does. Science doesn't show you reality, but it does show you the patterns in your interface that are consistent, reproducible, predictive. And by studying those patterns, you can learn to navigate the interface more effectively. You can't see ultraviolet light, but you can build a camera that detects it and translates it into visible wavelengths. You can't see bacteria, but you can build a microscope. You can't perceive quantum fields, but you can build equations that describe them and experiments that test them. You're extending your perceptual reach not by changing your biology, but by building prosthetic senses, artificial interfaces that access information your natural senses can't. And this is powerful. This is how we've discovered things that no human could ever perceive directly. Black holes, DNA, the cosmic microwave background, the expansion of the universe. We're not seeing these things. Not really. We're seeing representations of them, models, translations, filtered through instruments in mathematics and theory. But those representations are grounded in something real. They're not arbitrary. They're constrained by the structure of whatever's out there. So even though you can't access reality directly, you can triangulate, you can approach it from multiple angles, using multiple instruments, multiple frameworks, and the overlapping patterns that emerge, the places where all the maps agree, those are your best guess at what the territory actually looks like. It's not perfect, it's not complete, but it's better than staying locked inside your unaided perception, convinced that what you see is all there is. The history of science is a history of discovering that things are not what they seem. The Earth seems flat, but it's round. The sun seems to orbit the Earth, but it's the other way around. Matter seems solid, but it's mostly empty space. Time seems absolute, but it's relative. Every discovery is a revelation of hidden complexity, a peeling back of the interface to reveal something stranger, something deeper. And this process never ends. Every answer raises new questions. Every solved mystery reveals new mysteries. We used to think atoms were the smallest things. Then we discovered protons, neutrons, and electrons. Then we discovered quarks and leptons. And now we're wondering if maybe strings or loops or fields are the truly fundamental things. But each time we dig deeper, we hit the same wall. The tools we're using to dig are themselves made of the thing we're trying to understand. We're using matter to study matter, using consciousness to study consciousness, using perception to study perception. It's like trying to see your own eye without a mirror. You can describe its effects, you can study its structure, but you can never see it directly because it's the tool you're using to see. This is the fundamental limit of knowledge. You can't step outside your own perspective. You can't observe without being an observer. And the observer changes the observation. This doesn't mean knowledge is impossible. It just means knowledge is always partial, always perspectival, always incomplete. You're building maps, and maps are useful, but the territory remains forever out of reach. And maybe that's okay. Maybe the search for absolute objective truth is a fool's errand. Maybe the goal was never to find the ultimate answer, but to keep asking better questions. Because here's the thing about accepting that your perception is limited. It makes you humble. It makes you curious. It makes you realize that no matter how much you know, there's always more to discover. And it makes you appreciate the mystery. Because if you could see reality as it truly is, if you could strip away all the filters and all the interfaces and stand face to face with the raw, unmediated truth, what would you see? Maybe nothing. Maybe something so alien, so incomprehensible, so far beyond the capacity of your brain to process that it would be indistinguishable from chaos. Or maybe something beautiful, something that would make all the filtered, edited, simplified versions you've been experiencing seem like shadows on a cave wall. You'll never know. And that's the tragedy and the beauty of being human. You're trapped inside a magnificent lie, a carefully constructed illusion that allows you to function, to survive, to thrive. And the lie is so convincing, so seamless, so complete that most of the time you don't even realize it's a lie. But every once in a while, you catch a glimpse, a moment where the interface glitches, a moment where you feel the strangeness of being a conscious observer in a universe that doesn't owe you an explanation. And in that moment, you realize the world is not what it seems, and you are not what you seem. And maybe that's okay. Let's take a breath. Let's step back from the abyss. We've spent this entire journey dismantling your perception, showing you all the ways your brain lies to you, all the ways reality might be different from what you experience. And that can be unsettling. It can make the world feel less solid, less reliable, less real. But here's the reframe. What if the interface isn't a prison? What if it's a gift? Yes, your perception filters reality. Yes, your brain constructs a simplified, edited version of the world, but that simplification is what makes life possible. Imagine if you could perceive everything. Imagine if your brain didn't filter out the 99% of electromagnetic radiation you're blind to. Imagine if you could see every wavelength, feel every neutrino, hear every frequency. You'd be overwhelmed. paralyzed, drowning in information. The interface protects you. It curates reality for you, selecting the bits of information that are relevant, useful, meaningful, and discarding the rest. It turns the blooming, buzzing confusion of the raw universe into something you can navigate. And more than that, it gives you beauty. The redness of red, the sweetness of sugar, the warmth of sunlight on your skin, these are gifts. They're not real in the objective sense, but they're real to you. They're the felt texture of your existence. Reality might be colorless, but your experience isn't. And that experience, that subjective first-person qualia-rich journey through life, is the only reality you'll ever know. So why not embrace it? Here's another way to think about it. You're not seeing reality. You're seeing a story, a narrative, a beautifully rendered moment-by-moment story about a person, you, moving through a world. And stories have meaning. Stories have emotional weight. Stories can be tragic, joyful, redemptive, mysterious. The universe in its raw form has no story. It's just particles obeying laws, fields fluctuating, entropy increasing. It's mechanics, it's math, it's impersonal. But your perception turns that mechanics into meaning. It turns the cold equations into a lived experience. It takes the indifferent universe and makes it matter. And that mattering, that meaning, is not a bug. It's the feature. It's the point. You're not here to see reality as it truly is. You're here to experience it in this particular human, filtered way. To feel the warmth of the sun, to taste the sweetness of ripe fruit, to hear music, to love, to wonder, to fear, to hope. These experiences are constructed, but they're not less real because of that. They're your reality, and they're valid. The fact that color is an invention of your visual cortex doesn't make a sunset less beautiful. The fact that sound is air molecules vibrating doesn't make music less moving. The fact that your sense of self is a construct doesn't make your relationships less meaningful. The interface is where you live. And it's enough. You don't need to see behind the curtain. You don't need to access the nominal realm. You don't need to perceive the universe as it truly is, whatever that means. You just need to be here in this moment, in this body, in this perceptual bubble, experiencing this strange, limited, beautiful, tragic, temporary life. And that's okay. That's more than okay. That's everything. Let's talk about dreams for a moment, because dreams are a perfect metaphor for what we've been discussing. When you're dreaming, you're fully immersed in the dream world. It feels real. You don't question it. You accept the logic of the dream, even when that logic is absurd. You see people who don't exist, visit places that aren't real, experience emotions tied to events that never happened. And while you're in the dream, none of that matters. The dream is your reality. It's the only reality you have access to. Then you wake up and you realize, oh, that was a dream. It wasn't real. It was just my brain generating a simulation while I slept. But here's the thing. While you were dreaming, the dream was real to you. The emotions were real. The experiences were real. And in a sense, they still are, because they happened in your consciousness. And consciousness is the only place where things can happen. Now, apply that to your waking life. You're experiencing this world, this body, this moment. It feels real. It feels solid. But what if it's just a more sophisticated dream? A longer, more coherent, more consistent simulation generated by your brain while you're, what? Alive? Does it matter? Does it make your experiences less valid if they're happening in a simulation, whether biological or otherwise? No. Because validity is not about correspondence to some external, objective reality. Validity is about coherence, consistency, and meaning. And your experiences have all of those. You're living in a dream that makes sense, a dream that follows rules, a dream that allows you to interact with others, to learn, to grow, to change. And when you finally wake up, you might realize that this dream was the point. Not a distraction from reality, but reality itself. It's late now. You've been on this journey for a while, and your mind is probably tired. Tired of questions, tired of uncertainty, tired of the abyss. So let's come back. Let's come back to something simple, something grounding. You're lying down or sitting or wherever you are right now. Feel your body. Feel the weight of it. Feel the surface beneath you, supporting you. Yes, we know it's not solid. We know it's mostly empty space and electromagnetic repulsion, but it still feels solid. And that feeling is real. It's your experience. And your experience is all you have. Feel your breath, in and out, slow and steady. The air moving through your lungs, oxygenating your blood, keeping you alive. Yes, we know air is just molecules, nitrogen and oxygen bouncing around randomly. But it's also the breath of life. It's the rhythm that connects you to the world, and that connection is real. Listen to the sounds around you. Maybe there's silence, maybe there's the hum of a distant appliance, the sound of wind, the murmur of voices. Yes, we know sound is just vibrations, but those vibrations are creating your sonic reality, and that reality is comforting. It's familiar. It's home. You don't need to understand reality to live in it. You don't need to pierce the veil to see behind the interface to access the thing in itself. You just need to be here, present, aware, accepting. The world is full of mysteries. Your perception is limited, your knowledge is incomplete, and that's okay, because the questions, the seeking, the wondering, that's part of being human, that's part of the experience. And the not knowing, the uncertainty, the vast unknown stretching out beyond the edges of your understanding, that's not a void to be feared. It's a space to be wondered at. You're a small temporary pattern in an incomprehensibly large universe. You're a brief flicker of consciousness in an ocean of unconscious matter. You're a single note in a symphony you'll never hear in its entirety. And that's beautiful, because you're here. You exist. You get to experience this moment, this breath, this thought. And no amount of filtering, no amount of distortion, no amount of evolutionary lying can take away the simple fact that you are having an experience. Right now. This one. The universe doesn't owe you an explanation. It doesn't owe you clarity. It doesn't owe you truth. But it gave you this. A perceptual system that turns raw data into meaning. A brain that constructs stories, finds patterns, creates beauty. A consciousness that can reflect on itself, ask questions, seek answers. You're the universe experiencing itself. You're the cosmos waking up and looking around and asking, what is this? Who am I? Why am I here? And the universe doesn't answer. It just keeps unfolding, indifferent and magnificent. But you keep asking, and that's enough. Let your mind rest now. Let the questions fade. Let the uncertainties dissolve. You've looked into the abyss. You've seen the limits of perception, the fragility of self, the strangeness of reality, and you've come back. You're still here, still breathing, still experiencing. The interface is still running. The story is still unfolding. The dream is still dreaming. And for now, that's all you need. Your eyelids are getting heavy. The weight of thought, the burden of knowing, it's all settling into your body, making you sink deeper into rest. You've traveled far. You've ventured into the hidden mechanics of perception, seen the filters your brain uses, understood the limits of your senses, and you've discovered something paradoxical. The more you learn about how limited your perception is, the more you appreciate the miracle of perceiving it all. You can't see the full spectrum, but you can see light. You can't hear all frequencies, but you can hear music. You can't feel magnetic fields, but you can feel warmth. And that's enough. That's always been enough. Let your thoughts slow down. Let them drift, like clouds passing across the sky of your mind, observed but not held, noticed but not grasped. You don't need to solve anything tonight. You don't need to understand everything. You don't need to find the ultimate truth. You just need to rest, to let go, to trust that the world will still be there tomorrow, just as strange, just as mysterious, just as beautiful. Your brain has been working hard, filtering reality, constructing your experience, keeping you alive. Let it rest now. Let it do its nighttime work, processing memories, consolidating learning, dreaming its strange dreams. You're safe in the interface. You're safe in the illusion. You're safe in the dream. Think of the stars, billions of them, scattered across the night sky, each one a sun, each one a world of light and heat and energy. You can't see most of them. They're too far away, their light too dim, or hidden behind dust and gas. But the ones you can see, they're enough. They're beautiful. They're awe-inspiring. You don't need to see every star to feel the vastness of the universe. You don't need to understand every wavelength to appreciate the night sky. You just need to look up and wonder, and let yourself feel small in the best possible way. Your perception is a gift, not a prison. It's a carefully curated experience designed to help you survive, yes, but also designed to help you thrive, to help you find meaning, to help you connect, to help you love. The colors you see, even though they're constructs, allow you to navigate the world with grace. The sounds you hear, even though they're translations, allow you to communicate, to share, to understand. The sense of self you carry, even though it's a narrative, allows you to move through time, to learn from the past, to plan for the future, to be someone. These are gifts, and they're yours. Let yourself drift now. Let the boundary between waking and sleeping blur. Let your conscious mind step back and let the deeper processes take over. Your brain knows how to sleep. Your body knows how to rest. You don't have to control it. You don't have to guide it. Just let go. Breathe in slowly. Hold for a moment. Breathe out even slower. With each breath, feel yourself sinking deeper, deeper into relaxation, deeper into rest, deeper into the quiet comfort of simply being. The questions can wait. The mysteries can wait. The universe isn't going anywhere, and neither are you. Not tonight. Tonight, you're here. Safe, warm, resting. You are not separate from the world. You are a part of it. A small, temporary, beautiful part. And when you close your eyes, when you surrender to sleep, you're not disappearing. You're just changing states, shifting from one mode of consciousness to another. The world continues. Your brain continues. The story continues. But for now, you rest. Let your muscles soften. Let your jaw unclench. Let your shoulders drop. Feel the tension draining out of your body, flowing away, leaving you loose and heavy and still. Your mind is quiet now. The chatter has faded. The analysis has stopped. You're just here, just breathing, just being. And that's perfect. In the morning, you'll wake up. The interface will boot up again. The world will reconstruct itself around you. Familiar and strange, solid and illusory, real and unreal all at once. But tonight, you let it all go. You release your grip on reality, knowing it was never really yours to hold in the first place. You're a wave, remember? Not a particle. And waves rise and fall, crest and dissolve, always part of the ocean, never separate from it. So sleep now. Let the dream take over. Let the unconscious mind do its work. You've learned that your perception is limited, that your senses filter reality, that your brain constructs a simplified version of the world. But you've also learned that this is okay, that limitation is not loss, that the interface is not a barrier, it's a translator, it's a storyteller. And the story it's telling, the story of your life, of your experiences, of your consciousness, is worth telling. Even if it's a dream, even if it's an illusion, even if it's just a pattern of electrical activity in a mass of neurons. It's your dream, your illusion, your pattern, and it's beautiful. Rest now. The universe will keep spinning, the stars will keep burning, the quantum fields will keep fluctuating. And tomorrow you'll wake up and see it all again through your limited, filtered, beautiful human perception, and it will be enough. It's always been enough. Sleep well.